Hi, this is Lipika from Gretel. Today we're going to be covering synthetic performance. So one of the most important questions that you might have after training a synthetic model in Gretel might be, how good is my data? So here I have trained a model on airplane accident severity. That's the data set from Kaggle. I went through, trained the model, and to determine the quality, I'm going to look at the report. And here we have a quick overview of a few metrics which we can delve into in the synthetic report that can be downloaded here. If you click that, it'll open up this HTML. And here you have up top two big metrics, the synthetic data quality score and the privacy protection level. The synthetic data quality score is an estimate of how well the generated synthetic data maintains the same statistical properties as the original data set. And the privacy protection level, which is determined by the mechanisms that have been enabled in the synthetic configuration that are privacy related. So here we have three components of the synthetic data quality score: field correlation stability, deep structure stability, and field distribution stability. We also have a quick overview of the train and synthetic sets, the number of rows that we use to generate this report, the number of columns in each data set, and most importantly, the number of training lines duplicated. Here we see that 0 training lines were duplicated, which is a win for privacy. Moving on, we can see that in the configuration while training this model, we had outlier filters on and similarity filters on. These are part of our privacy filters that are applied after a model is trained on each synthetic data set that is produced. You can also see that overfitting prevention was on, and here only stopping and or validation or the use of a validation set happened. So that's why we have ended up with a privacy protection level that's very good. All right, so to delve into the quality side of the house a little bit more, we have a training field overview, which provides some information about each field in this data set and an indication of its distribution stability. In this case, all excellent, and we'll see a little bit more of that further down. The next component is data correlations in the training and synthetic sets. So we compute correlations between variables pairwise in the training set and the synthetic set, and we determine the correlation difference between them. So for example, the correlation difference between severity and adverse weather metric in the train set was 0.16, in the synthetic set was 0.22, and we end up with a correlation difference of 0.06. Further down, we can see the principal component analysis of this data set. So this data set has 13 different columns. We are reducing the dimensionality of this data set using PCA to visualize it in 2 dimensions here with the first and second principal components. And basically we're looking for visual confirmation that the shapes of these 2 distributions are roughly the same. We can see that they're both centered around 0, 0, and the spread is roughly equal. Finally, we have field distribution comparisons. And here we're seeing for each column or each variable in the data set, what is the distribution in the train set and the synthetic set. So ideally, we'd like to see overlap between the two, between the purple and the green, which is certainly the case here. All right, and that's all we got for our synthetic data report.